Alright, so this problem is a multiple choice problem involving Kp, and what I've done is I've set up my ice table and I've written my equation for Kp. Now, we know some information from the problem. The first thing is that we formed 2 atmospheres of the SO3, so I'm going to fill that in onto my ice table. The other thing we know is that initially the amounts of SO2 and O2 were equal to each other. We also can assume that we're starting with 0 of the SO3. Now, we know that if we started at 0 and end at 2 atm, then the change is positive 2 atm. If the change is positive 2 atm, this is related to the coefficient. Since the coefficient is 2, we can fill in the change on the other side of the equation. This is going to be minus 2 atm, and this one is going to be minus 1 atm, since the coefficients are 2 and 1, respectively. Alright, so we have this information. Now we know one more thing in the problem, and this is a really important point, and it says half of the initial SO2 reacted. So if we know that 2 reacted, we know we must have started with 4 atmospheres. And we were also told at the beginning of the problem that the SO2 and the O2 were equal. So that is also going to be 4 initially. So since we know that those are 4, when I fill in the equilibrium value for the SO2, that's going to be 2, just 4 minus 2. And for the equilibrium of the O2, that's 4 minus 1, so that's 3. Now we can take these values and plug them into our Kp expression. So Kp is equal to SO3 squared, 2.00 squared, over SO2 squared, so that's 2 again squared, times the O2, which is 3.00, and that one's raised to the first power. Now, just to make the math easy, we know that 2 squared over 2 squared, those are going to cancel out and just make 1. So our Kp is equal to 1/3, which is 0.333, which gives us the choice B in our multiple choice.